sulfide, is an inorganic anion of sulfur with the chemical formula S2A. It contributes no color to sulfide salts. As it is classified as a strong base, even dilute solutions of salts such as sodium sulfide are corrosive and can attack the skin. Sulfide is the simplest sulfur anion. Nomenclature: the systematic names sulfondiide and sulfide, two valid IUPAC names, are determined according to the substitutive and additive nomenclatures, respectively. However, the name sulfide is also used in compositional IUPAC nomenclature which does not take the nature of bonding involved. Examples of such naming are selenium disulfide and titanium sulfide, which contains no sulfide ions whatsoever. Sulfide is also used non-systematically, to describe compounds which releases hydrogen sulfide upon acidification, or a compound that otherwise incorporates sulfur in some form, such as dimethyl sulfide. Hydrogen sulfide is itself an example of a non-systematic name of this nature. However, it is also a trivial name, and the preferred IUPAC name for sulfane. Chemical properties: sulfide does not exist in appreciable concentrations even in highly alkaline water, being undetectable at pH 15. Basicity: the sulfide anion can assimilate a proton by recombination, S2A plus H plus a SHA. Because of this capture of a proton, sulfide has basic character. In aqueous solution, it has a pKb value of less than 0. Its conjugate acid is bisulfide. In aqueous solution, most sulfide ions are neutralized. S2A plus H2O SHA plus OA, chemical reactions: upon treatment with a standard acid, sulfide converts to hydrogen sulfide and a metal salt. Oxidation of sulfide gives sulfur or sulfate. Metal sulfides are mildly corroded by known metals including iodine, bromine, and chlorine forming sulfur and metal salts. 8MgS plus 8OI2S8 plus 8MgI2. Sulfur can also be prepared from a metal sulfide and an appropriate oxidizer, 8Na2S plus 16O, 3 plus 32H plus AS8 plus 16ONO2 plus 16OH2O. Metal derivatives: aqueous solutions of transition metals cations react with sulfide sources to precipitate solid sulfides. Such inorganic sulfides typically have very low solubility in water, and many are related to minerals with the same composition. One famous example is the bright yellow species CDS or cadmium yellow. The black tarnish formed on sterling silver is Ag2S. Such species are sometimes referred to as salts. In fact, the bonding in transition metal sulfides is highly covalent, which gives rise to their semiconductor properties, which in turn is related to the deep colors. Several have practical applications as pigments, in solar cells, and as catalysts. Aspergillus niger plays a role in the solubilization of heavy metal sulfides. Geology: many important metal ores are sulfides. Significant examples include argentite, cinnabar, galena, molybdenite, pentlandite, realgar, and stibnite, sphalerite, and pyrite, and chalcopyrite. Corrosion induced by sulfide: dissolved free sulfides are very aggressive species for the corrosion of many metals such as steel, stainless steel, and copper. Sulfides present in aqueous solution are responsible for stress corrosion cracking of steel, and is also known as sulfide stress cracking. Corrosion is a major concern in many industrial installations processing sulfides, sulfide ore mills, deep oil wells, pipeline transporting soured oil, craft paper factories. Microbially induced corrosion or biogenic sulfide corrosion are also caused by sulfate-reducing bacteria producing sulfide. Oxidation of sulfide can also form thiosulfate, an intermediate species responsible for severe problems of pitting corrosion of steel and stainless steel, while the medium is also acidified by the production of sulfuric acid when oxidation is more advanced. Organic chemistry: in organic chemistry, sulfide usually refers to the linkage CSC, although the term thioether is less ambiguous. For example, the thioether dimethyl sulfide is CH3SCH3. Polyvinylene sulfide has the empirical formula C6H4S. Occasionally, the term sulfide refers to molecules containing the Sh functional group. For example, methyl sulfide can mean CH3Sh. The preferred descriptor for such containing compounds is THIOL or mercaptan, that is methanethyl, or methyl mercaptan. Disulfides, confusion arises from the different meanings of the term disulfide. Molybdenum disulfide consists of separated sulfide centers, in association with molybdenum in the formal 4+ oxidation state. Iron disulfide on the other hand consists of S22A, or azar-dianion, in association with divalent iron in the formal 2+ oxidation state. Dimethyl disulfide has the chemical binding CH3-Za-SCH3, whereas carbon disulfide has no Za-S bond, being S=C=S. Most often in sulfur chemistry and in biochemistry, the disulfide term is commonly ascribed to the sulfur analogue of the peroxide O-O bond. The disulfide bond plays a major role in the conformation of proteins and in the catalytic activity of enzymes. Examples: preparation. Sulfide compounds can be prepared in several different ways. 1. Direct combination of elements, example Fe, S, plus S, S, Fe-S, S. 2. Reduction of a sulfate, example MgSO4, S, plus 4C, S, MgS, S, plus 4CO, G. 3. Precipitation of an insoluble sulfide, example M2 plus H2S, G, Mis, S, plus 2 hours plus, AC. Safety. Many metal sulfides are so insoluble in water that they are probably not very toxic. Some metal sulfides, when exposed to a strong mineral acid, including gastric acids, will release toxic hydrogen sulfide. Organic sulfides are highly flammable. When a sulfide burns it produces sulfur dioxide gas. Hydrogen sulfide, some of its salts, and almost all organic sulfides have a strong and putrid stench. Rotting biomass releases these. See also, dithanite, sulfate, sulfide stress cracking, sulfate, tetrathionate, thioester, thiosulfate. References